So for example 3 for this cross-sectional area that gives us volume, we're going to intentionally look for the magic words that say set up but don't integrate. So this is a great way for an AP or a teacher to ask you to do something really complicated without making you do this gut buster of a problem with tons of fractions and foiling and misery. So requiring you to set up but not integrate indicates that you know how the problem should work, but that you're not absolutely destroying yourself with the content of adding fractions and multiplying and common denominators and just lots and lots of tedious stuff. So it's a great way to check for calc knowledge without beating you over the head about your algebra knowledge and your pre-algebra knowledge. So we're using the same area that we had in example 2, actually. We have y equals the square root of x, and we have x equals 4. But this time, it's worth noting that my cross-sections are perpendicular to the x-axis in all situations. And I picked 2 that are pretty common. So the first one I picked is rectangles, where they give you some defined height that is a multiple of the base. And the second one I picked is equilateral triangles. The only reason I know the area of an equilateral triangle in terms of its base is this problem. And as a math teacher, I've done it so many times that I have it memorized, but I want to show you how to logic through it if you need it. So what I'm going to do is I'm going to start with A, which is rectangles whose height is 8 times their base. So the base is in the region. So what we're looking at is we're looking at some base randomly somewhere in the middle that looks like this. And then coming off the paper is a rectangle that has a crazy big height that is 8 times that area. Or 8 times that length, rather, not an area. So I'm going to erase this B for a sec so we have some room. So essentially, my rectangle has this base and this height that is definitely just 8 base, right? Like 8 times the height. So remember that our job is to find an area formula. In this case, because we're perpendicular to the x-axis, I want my area formula in terms of x. So when we're asked to find a length in the xy plane that is vertical, we always do the top value, which would be the square root of x, minus the bottom value, which is 0. So this base is top value, root x, minus bottom value, which is just the x-axis, so 0. So my base is just root x, which means that my area in terms of x is 8 times the base, right? Because it's base times height. So I think it's just going to be an 8 times root x, right? So my area, after all that work, ends up just being an 8x. Now, this is one where you actually could be asked to integrate because it wasn't terrible. Remember that my volume is not just the area, but my volume is the integral of the area over that whole window. Since I'm integrating with respect to x, I want to start where x is 0, that's the first dish, and end where x is 4. So my volume is going to be the integral from 0 to 4 of 8x with respect to x. Because I said set up and don't integrate, that's it. You don't have to integrate. That's your volume. Congratulations. Again, this is one that's not awful, so if you had wanted to integrate, it's definitely doable to integrate, but we're not going to because I said we weren't going to, so I'm going to stick by it. I'm going to erase this one and do our part B. So if I erase my A, right? So for part B, now this is a little bit trickier, right? So now instead of this, I'm going to completely wreck this, but that's fine. So instead of this rectangle, right, what I now have here are these equilateral triangles. So for my part B, I have an equilateral triangle. And I'm going to give you some like SAT, PTSD in a second, but you'll survive. So coming out of here is an equilateral triangle as my plate. So it's coming up out of the board. So let's look at an equilateral triangle for a sec. So we have this base in an equilateral triangle. That base is a thing we're going to be able to find, right? That base is going to be top minus bottom. We've already seen it in the last problem. It's going to be a root x minus a 0. So that base is a root x, no big deal. What's hard here is how we define the area of a equilateral triangle when we don't have the height, right? So what I want you to consider about an equilateral triangle is that an equilateral triangle has the same sides in every direction, right? Which also means it has the same angles, right? So these are all 60 degrees, and I know we usually do radians when we talk about calc, but in this situation, we're going to look for a second at half of this triangle. So this is a 60-degree angle, and this is a 30-degree angle, and this is a right angle. This side's a B, and this side's a B over 2 because I took this whole base on the bottom and cut it in half. I'm pretty sure that this is a 30, 60, 90 triangle, right? So I'm pretty sure that this missing side, if we look at the ratio of a 30, 60, 90 triangle, so if you think back to some SAT shenanigans, right? So if this is my 30, and I apologize that my markers are not the clearest at this small amount, my ratios in a 30, 60, 90 triangle are 1 to 2 to root 3, right? So if we look at those ratios, we can figure out this height of this triangle in terms of base, right? We can say essentially that the height is to the base, as the root 3 is to a 2, so my height is root 3 over 2 times base. Once I know that the area of an equilateral triangle, which is 1/2 base times height, would be 1/2 base times this root 3 over 2 base, so you get that the area is a root 3 over 4 base squared. That's the formula for the area of an equilateral triangle. Once you know that, you already have your formula for base. Your base was just a root x. So this is for any, right? This is any equilateral triangle. And again, the only reason I have it memorized is because I do a lot of calc. So if I go over here to finish out my problem, I say, oh look, well my base in this problem, so my area with respect to x, is root 3 over 4 times my base, which is root x, quantity squared. So I get that my area with respect to x is a root 3 over 4 times an x, which again, it turns out that after all this work, I actually could have made you integrate this because it's not awful. So my volume is what happens if I integrate from the first-ish, which was at 0, to the last-ish, which was at 4. So from 0 to 4 of root 3 over 4x with respect to x. And that is all you need to do because I didn't ask you to integrate.